Alright, welcome back to Calc Notes 9.5. This is part 2 of the video. We're actually going to start to use the formula, the binomial theorem formula, to actually expand binomials. So our first example is if we have x plus 2y to the 5th power, and I want you to expand that. So the first rule is to always draw your blanks, and you want to give yourself a lot of room to do this. I'm going to give myself, because the exponent is 5, I'm going to give myself 6 blanks. And then what I'm going to do is I'm going to go ahead and fill in my coefficients. So my coefficients will be, if there's 6 blanks, it would be the 6th row. 1, 2, 3, 4, 5, 6 would be this. So start off with a 1, then a 5, a 10, a 10, a 5, and a 1. Then what I'm going to do is I'm going to take my first term is an x, so I'll put an x here, and I'll put whatever my exponent is, 5. And as I work my way down the blanks, I put one less exponent each time. 3, 2, 1, and then no x's at all. Then I work with the y's, in this case a 2y. So I've got 2y raised to the 0 power. Then I've got 2y raised to the 1st power, 2nd, 3rd, 4th, and 5th. Now notice I wrote this as 2y raised to the 0. Here I didn't write this as x raised to the 0, because remember that when you raise it to the 0 power, it's really the same as 1. So it's not there. I deliberately put it in the first blank because if we tend to forget to put it in the first blank, then we usually write it to the 1st power there. Remember, you have no y's in the first blank, then 1, 2, 3, 4, and 5. Alright, so as I go through and simplify this, 1x to the 5th is just x to the 5th. And then here, I end up having 5 times 2 raised to the 1st power, so that's just 2, so I end up with 5 times 2 here, so 10 x to the 4th y. For this one, I have a 10, then I'm going to times that by 2 to the 2nd power, which is 4, so I'm going to end up with 40. And then my exponents would be x to the 3rd, y to the 2nd. Over here, I've got 10, and I'm going to times that by 2 to the 3rd, which is 8, so that makes 80 x squared y to the 3rd. Here, I'm going to have this 5, and I'm going to times that by 2 to the 4th power, which is 16, and that's going to give me 80 again, x y to the 4th, and finally I have 1, I'm going to times by 2 to the 5th power, which is 32, so it's going to be plus 32 y to the 5th. And so this is going to be my answer to this binomial expanded. Let's look at another example. Alright, so looking at this, I've got an x minus 3 raised to the 4th power. So I'm going to give myself 5 blanks. And as I look at this, the coefficients would be, and I don't have Pascal's triangle on the video, but you go back to your notes, we're looking at the 5th row of Pascal's triangle. Our coefficients would be 1, 4, 6, 4, and 1. Alright, so we start off by taking the first term, which is x, raise it to our highest exponent is 4, 3, 2, 1, and then no x's at all. Here, we're going to take our second term, and I made sure that we recognize that it's a negative 3 raised to the 0 power, then the 1st, 2nd, 3rd, and 4th. And then we can go through and we can figure out what this reduces down to. Now, negative 3 raised to the 0 power is 1, so this is just x to the 4th. I'm not going to put my sign here yet because that's going to be denoted by what the coefficient is of whether that's positive or negative. So I'm going to have 4, and I'm going to times that by a negative 3, so I'm going to end up with negative 12x to the 3rd. And then for this one, I'm going to have 6, and I'll have to times that by a positive 9, so I'd end up with positive 54. It's positive because the fact that I get a positive 54 here. So you get this sign whether it's positive or negative based upon whether your coefficient is a positive or a negative coefficient. For the next one, this is going to be 4 times negative 27, and that's going to give me negative 108, and I would just have an x there. And then over here, negative 3 raised to the 4th power is positive 81, so I would just have plus 81. And that would be the expanded form of my binomial. So pay attention to whether your number here is positive or negative. That makes a big difference when you're solving these. If we didn't put this in as a negative 3, if I just used a positive 3, then I wouldn't have got this alternating pattern sign between the negative to positive, negative and positive. And you're going to notice that that's going to happen when you have this binomial as a minus there. The next one asks us to find the term involving the x to the third. So I'm not actually going to find the whole entire thing. What I'm going to do, if I want to get started here, is thinking about finding the x to the third term. So I know I'm going to have x to the third here with this. And then my second term, negative 3y, I have to figure out what is the exponent that I need to add to raise that to. And so this rule right here is going to be really helpful in that. Remember that the exponents must add up to 14, because that's what this is. So if this has 13, then this has to have a 1 with it. And I just noticed that that says 3, not 13. So let me go back for a minute and change that. Sorry about that. So if this is a 3, x to the third power, this is not going to be 1 then. So I would have to have this be an 11, because 3 and 11 make 14. Okay, so again, I write down the x to the third, and then I recognize that the second term has to have an exponent that would make these add up to be 14. Now how do I find my coefficient? I could use Pascal's triangle, but I don't have 15 rows of that. So I'm going to have to go back to my combinations. So because there's 14 here, I do 14 combinations of 3, or I can do 14 combinations of 11. Either one of these answers is going to give me the right coefficient. And that coefficient ends up being, both of these give me a 364. So again, I just use my calculator to find that. Okay, so now I got a little bit of work to do here. I'm going to have to do 364 times negative 3 raised to the 11th power to get my actual coefficient. And I know that negative 3 to the 11th power is negative 177,147. So if I times that by 364, I end up with negative 64,481,508. And then I got to put my x's and y's with it. X to the third, y to the 11th. So you have to be careful when you're doing this. This coefficient that you get from here, from using either Pascal's triangle, or in this case we used combinations, is not always going to be your final answer for the coefficient. Because of the fact that you had a negative 3 in here that you're raising to the 11th power, you've got to figure out what that number is, multiply it by that 364 to get your actual coefficient for that term of the expanded binomial.